Hello, I'm Bose. Welcome to my channel, Learningbuildslife, and today we're going to talk about what Ohm's Law Graph is. To explain Ohm's Law Graph with an example, we have taken a problem. Put the VI graph for a conductor having 5 ohms resistance at a constant temperature. Now, we have written at a constant temperature because it's very important to mention that what are the temperature conditions, as fluctuation in temperature can lead to fluctuation in the resistance. Hence, it's really important to mention whether it's in constant temperature or not. These are our conditions. Now, before we begin, we have to think of a table of PD, explaining the relationship between PD and electric current. That means potential difference versus electric current. Like, for example, if there is 0 potential difference at 2 ends of a conductor, then there is 0 amperes of electricity flowing through it, because we have 5 ohms resistance here, and I'm telling that this won't result in 5 ohms, but the formula of resistance suggests V by I. V by I, that means in any case, if the volt is changed, then the I has to be changed in such a way that it results in 5 ohms resistance as per our question. Like in this another case, if there's 5 volts of potential difference, then there is 1 ampere of electricity flowing through, electric current flowing through that conductor, because 5 by 1 is 5. Similarly, 10 volts means 2 amperes, 15 volts means 3 amperes, 20 volts means 4 amperes, and like that. And 25 volts means 5 amperes. Now we need to represent this in a graphical form, like over here. Now I'm explaining you this graph very carefully. First, we have our x-axis over here, which is the horizontal line, x-axis, and our vertical line is our y-axis. We have taken the volts, that is the potential difference in the x-axis, and we have taken the amperes in the y-axis. And here it's written the VI. Now I'm explaining to you what is VI graph, voltage and electricity. Electric current and volts, electric current and volts graph. Hence, here V and here I. We can call this an Ohm's Law graph, or it's a VI graph. You can call any of them. It's x and y axis. So in our first thing, we have 0. 0 is the origin of this graph. Here it's written the VI graph is a straight line passing through the origin. Here the origin is 0. That means here if there is 0 ampere, means if there are 0 volts, that means 0 potential difference across the 2 ends of a conductor, then there is 0 amperes of electric current flowing through that. Then if we go a step forward, our coordinate is 5, 1, because if we have 5 volts, we have 1 ampere of electricity flowing through that conductor. And this is our coordinate in the graph. We first express the component of the x-axis, and then we express the component of the y-axis. Similarly, 10, 2 is one of the coordinates, and these are other coordinates like 15, 3, 20, 4, 25, 5, and finally 30, 6. This is how we express the Ohm's Law graph. It is basically the VI graph is a straight line passing through the origin. But there is an important thing, that if there are temperature fluctuations, then this graph won't be as smooth as it is. It won't be a straight line like this. If there are temperature fluctuations, there will be fluctuations in resistance that can cause different complications in the graph. So it won't be a straight line, but since in this problem we have it at a constant temperature, it's a straight line. I'm giving you a few moments to look at the board so that it can sharpen your concept. Hope you enjoyed learning with me, and please like, share, and subscribe my channel. Thank you.